Okay, welcome to the last example we're going to do today. There is an extension problem down below that's pretty tricky. The only thing that this problem kind of confuses people on are the negative exponents, which really isn't that bad. You just change to a fraction, okay? But we're not going to focus on that for today. We are going to focus on this last orange camel example. Okay, so the first thing we always want to do is we want to simplify the numerator and denominator separately. Okay, so the first thing we recognize here is our numerator is two fractions. It's not one simplified fraction, which is a problem. We need it to be. Okay, otherwise it makes our work very tough. So we're going to simplify this first. So we have 1 over x plus 1 over y. Now in the previous example, it's much easier to find a common denominator because we really only needed to change one of the terms. In this example, we need to change both of them, okay? So the easiest way to find a common denominator among two denominators that are not in common is to multiply the denominators together, okay? So let me get my blue arrow out a second. So ideally, we want these two fractions to have xy and xy as a denominator, okay? X goes into xy, okay? And y goes into xy. Just in the same way that if you're trying to find a common denominator with something like this, you could have 2 times 3, and you could get 6 as your common denominator for both of those, okay? That's kind of like an explanation of why we can multiply the denominators, and I think that helps most people, okay? But if you're a little confused, be sure to ask for help in class. I'm just going to leave this up here in small just as a little reminder why we can multiply the denominators, okay? So we have xy and xy as our denominator. Now the key is making sure the top makes it equal to our original fraction. We just can't put x over y and put a 1 up at the top because we changed the value of the problem, okay? We have to make sure it is balanced. So how do we keep 1 over x equal to a fraction with x over y in the denominator? Well, let's look at what we changed. We changed the denominator to have a y. We multiplied by y. So if we multiply by y in the denominator, to keep it balanced, we have to do 1 times y in the top, okay? Keep my plus sign. Now, just to show you real quick why it works, okay? If we cancel the y's, look what happens. It's the same value as before. These are equal, okay? That's why that works. We can do the exact same thing to the right with the 1 over y. So how do we make these two equal? Well, how do we change the bottom? We multiplied by x. See how that got multiplied in there? So if you multiply x to the base, we also have to do that to the top. So we multiply by top, and those could cancel, and it would be the same value. So these two fractions are equal, okay? And that's the whole point. We want to make sure that everything stays balanced and equal. Now we are free to go ahead and simplify. We can add the two fractions and leave the base as x over y, okay, because the bases are the same. So now we have 1 times y, which is just y, plus x. And we have to leave it like that because they are not like terms, okay? And that's okay. So we're going to rewrite this over here, y plus x over xy, okay? Now, let's go do the same thing with the bottom. As you recognize here in the bottom, we have 2 fractions. We want it to be 1 simplified, so let's go to work on this one. Very similar process, okay? So we have 1 over x squared minus 1 over y squared, and we need to find a common denominator. Now, the easiest way to find a common denominator is to multiply the bases. So we know our denominators are going to be x squared, y squared. Okay, let's look over here, x squared, y squared. Now, how do we go from 1 over x squared to here and keep it balanced? Well, if we multiplied the base by y squared, we need to multiply the top by y squared. So we have 1, which was in the top already, times y squared. Now we're going to keep the sign the same in between, minus. How do we go from 1 over y squared and keep it balanced? Well, we multiplied by x squared. Okay, so if we multiply by x squared in the bottom, we also have to do that in the top to keep it balanced. Okay, now we are ready to proceed and simplify. So the bottom, we keep the same when we add or subtract bases. And 1 times y squared is y squared. 1 times x squared is minus x squared. And that is our simplified bottom. So if we wanted to rewrite this whole compound fraction, let me copy and paste this real quick. Copy, paste. We could rewrite this whole fraction like this. I'm going to move it around a little bit and shorten it up. But we're not actually going to keep it like this because we're going to proceed with the reciprocal and multiplication, okay? But that fraction is the exact same thing as that one, okay? We just changed how it looked so that we can manipulate it a little bit easier and we can solve, okay? So what do we actually do? What we really want to do is we want to put y plus x over xy, and we want to multiply by the reciprocal of y squared minus x squared over x squared y squared, okay? So we're going to put x squared y squared in the top. Let me change that to green, actually. Sorry. Style, green. Okay? Divided by y squared minus x squared in the bottom. Okay? Now, do not just multiply all willy-nilly without simplifying first. Okay? So we can simplify a few things. Can we factor anything? No, can't factor that. Okay? That's already in its factored form. Okay? Nothing really, no common terms there. Look at this one. Okay? This is why chapter 5 was so important. We recognize that we have difference of squares. Okay? So we can factor that. Now, what else can we do? So we know we need to factor this, okay? So we're going to leave this in parentheses, and we'll get to that in a second. But can we cancel anything? Yes. We can cancel this x with one of these x's, because there's 2 of them there being multiplied together. We can cancel one of them. And we can cancel this y with that guy right there, leaving xy in the top. Okay? Now, in the top, the bottom is going to stay the same, okay? Y squared minus x squared, which we're going to factor in a second. But in the top, we're going to get y plus x, put that in parentheses, times xy, okay? We might be able to cancel later, so don't multiply that out yet, okay? Keep it in factored form. Now, how do we factor this guy? This is difference of squares, okay? So you should be able to recognize this, that you can go y minus x times y plus x. Now, once you put it into this form, you should recognize something. Now we can cancel even further. We can cancel this y plus x with this y plus x because it's all multiplication. So our most simplified form is xy over y minus x. And I bet you wouldn't have predicted that this monstrosity would turn all the way into this. But that is your final answer. Hope this helped. See you in class.